Hi guys, hope you all are well. Welcome to my channel Sutapa's Biology and I am Sutapa Datta. My today's topic is continuation of enzyme. Already I have made two videos on enzyme and this is my third video on enzyme. So in my last videos I have told you about the nature of the enzyme, its classification and etc. structure also, and today I am starting the most important part of the enzyme, that is the mechanism of enzyme action. Just follow the video, observe the video, watch the video up to the last of it, and then you will get many informations about the exams, and it's very important for the competitive exam, the topic enzyme. Okay, so starting mechanism of enzyme action. In this part, firstly, already I have told you that the substrate is known as ACE. Substrate is indicated as capital ACE. Enzyme as E. Enzyme substrate complex is ES and product is P. So in mechanism of enzyme action, firstly I am telling the first action is that the enzyme has its active site, already I have told you, and that according to that active site the structure of the substrate should be fitted, and the structure of the substrate should be at par with the active site of the enzyme. Now if enzyme is this, plus substrate should be in this structure, in this structure, that is, it should be closely fitted with the enzyme. So this is the enzyme and this is substrate. Now it's forming the enzyme substrate complex in this way. That they should be in close approximation. This close proximity is very much required for the breaking of the bond of substrate. So enzyme have to catalyze catalyze this by breaking the bond of the substrate, and that's only possible when the substrate is in more close proximation with the enzyme. So this is the formation of the enzyme substrate complex, and after that the enzyme will be released free as the product will not fit with the enzyme's active site. Suppose the product is like this, so it cannot be at par with the structure of the enzyme, so it will leave the enzyme and it will make the enzyme free for the next reaction. Okay, so this is the main thing of the mechanism of enzyme action. Firstly, the enzyme substrate get fitted with the active site of the enzyme, then formation of the enzyme substrate complex by breaking the bonds of the substrate, and then after chemical reaction completely the enzyme will make the substrate to the product, and then product will be of different structure and it will leave the enzyme permanently, and enzyme will be free for the next reaction. And this is the enzyme mechanism of enzyme action in short. And now I am giving you some models about it or hypothesis about this. There are two important or very prominent hypothesis or theory about this. That is, number one is lock and key hypothesis. Lock and key hypothesis. And Number 2 is Koshland's hypothesis, which is known as induced fit hypothesis. Induced fit hypothesis. So two main hypotheses are there, lock and key hypothesis and induced fit hypothesis. This one I am describing first. Lock and key, you know that in our regular life we use the lock and key, and the structure of the enzyme and substrate is compared with the lock and key here. Okay. Now here also the enzyme is the first structure, plus like like my previous model, it's also like this, same thing. It will form enzyme substrate complex, and lastly the enzyme is released as the product will be of different shape. Now what's the role of the lock and key here? Suppose this is the lock, enzyme is the lock. Lock has a groove and the key has to fit with that groove, and it's very specific that only one key can operate one lock. One key can operate one lock. So here also one enzyme can act on one substrate. So this is the specificity of the enzyme, and this hypothesis is for the enzymes which are substrate specific. Okay, so it should be of this kind, and then the key will fit with the lock and it will operate the lock. So structurally it's just like the lock is enzyme and key is lock is enzyme and key is substrate. But functionally the function of key is to operate the lock. Lock has no role in it. Key has to operate the lock. So enzyme is the key. Functionally enzyme is the key which can change the substrate. Okay, so structurally enzyme can be compared with the lock, and substrate can be enzyme can be compared at lock and substrate can be key. But functionally the opposite is that enzyme is the key and the substrate is the lock, as substrate has to be reach up to the product and enzyme has the operation on that to make it product, from substrate to product. Okay, this is about the lock and key hypothesis, and this was proposed by Emil Fischer. Emil Fischer, scientist Emil Fischer. Okay, so this is about the lock and key hypothesis, and this is the substrate. This hypothesis is only for the substrate specific enzymes. Okay, but in case of there are many enzymes. Later we have seen, and biochemists also they have seen that there are many enzymes which can act on a group of substrate. Okay, like aldolase, like dehydrogenase, etc. So in that case, how they will adjust? So this is about the induced fit hypothesis. Okay, so induced fit hypothesis is like that, which can, I am rubbing this, and induced fit hypothesis was proposed by Koshland. Already I have told you this is the Koshland's hypothesis, and induced fit means here the active site of the enzyme will compromise with the structure of the substrate. Okay, so in last hypothesis, Emil Fischer has told that the active site of the enzyme is very firm, it's not flexible. But in case of the induced fit hypothesis, the structure of the active site is flexible, but up to that extent which is possible for it. And what's the possibility and what's that? I'm telling that, suppose this is the enzyme and this is the active site. Now, there are many substrates, like one is like this. Other is like this. And any other, third is another one which is like this. Now this enzyme will take some substrates, more than one, but will it take all the substrates? These all are substrates. Now enzyme will compromise with whom? With this one enzyme I have no need to compromise because it's actor. Now this is not actor, this is not actor. Now how it will compromise? Suppose you have some teachers who can teach well, okay, but it's not understandable for you. Okay, suppose he or she is teaching you enzyme and you are understanding that the structure of the cell. So this is the absolute different and you can't compromise with this. And in case of teachers also, suppose I am teaching the subject enzyme and you are understanding the subject physiology. So it's not possible for me to teach you at all. So this compromisation is not possible. So there must be some limit. Now how can we tell about the enzymes compromisation level? Now there is the thinking that it's the 3-point test. 3-point touch. Now the enzyme, the substrate has to touch at least more than 3 points of the enzyme during reaction. Then only the enzyme will compromise with this. So in that case, this is most okay. This is not at all okay because it will just touch 1 point of the active site. So enzyme will not compromise with this. So it can't be act as substrate here. But this is also can be because it can touch more than 3 points of the enzyme's active site. I think it's clear to you. समझ में आया ना ठीक से? अगर नहीं आया तो कमेंट बॉक्स में जरूर बोलना, हम जो कमेंट बॉक्स फॉलो करेंगे फिर से हम ये एक्सप्लेन करेंगे, ओके? Because it's very important for you. Now the next is that enzyme will change itself in this way. So this is the modification of the active site of enzyme and this is the induced fate. That the enzyme structure is altered as induction of the substrate. So this is the modification of the substrate and then the next thing which is common with the other steps also. Enzyme will ultimately free itself. It will regain its structure and the product is like this. Okay, so this is about the question and hypothesis and today that's all about the mechanism of enzyme action. In my next video you will get about the different inhibition of enzyme action. Okay, for today it's bye.